I'm not sure if I'm getting very far. This was a question about probability distribution, the weekly demand for copier paper.
Okay.
What's different kind of than the prior one is they added in here, assuming that it costs the duplicating center $5 to purchase a ream, find the mean and standard deviation.
Right.
So this data in column A and B is given. C is the calculation based on the demand and probability.
Right.
And then I'm not sure the next column, can I basically multiply because it's $5 per ream.
Right. So, but you did it based on the probability, right?
Did I? Yeah. I did by C4 by correct. Well, I multiplied like here 2.5.
Right. Well, what is it asking you for?
What's the mean and standard deviation of the weekly copier paper cost?
Right. Okay. So I think instead of doing you're multiplying 5 by. Let me just think. I think because there's two ways to do this. If you do that one, you would get 50 times 0.05 would be 2.5. Okay, it'll actually be the same thing. Might have been easier, or might have been a little bit more intuitive if you had multiplied the demand by the $5, because if the demand was 10 and then you multiply by $5, that would be 50, but then you multiply it by the probability and you'll still get the 2.5. You see that?
Yeah.
Okay. You see that? Yes. So if I had taken the 5 and multiplied it by each of these numbers, you would end up with like 50 and 55 and so forth, right?
Yeah.
If you take then multiply that by the probability, like the 50, right? If you took 50 times 0.05, you're going to get your 2.5, which is this. It'll be the same way.
And then this is 55 times
0.10
is
which is 5.5. So you're going to get the same answer, okay? At that point. So that's correct. We can leave this as is.
So I sum this up.
Yeah.
You got 69.05.
Right.
And then over here I did the I subtracted demand by the sum, yeah. So 10 minus 69.05. 59.
Hold on a second. No. That's where you're wrong. So you're going to have to take, instead of A4, you're going to do D4.
Oh.
Because now you're working with this column here.
That's right.
Okay.
So it's D4.
Right. And then you copy that down.
So that space. Oh, it automatically changes everything else. Well, then.
Would hope so, yeah.
And then here.
Something doesn't look right. Hold on. Yeah. Can you go back to E column, please? E16. Okay, hold on one second, guys. Just, all right, let me see. What do we got here? You've got the 2.5. Our average should be 14. Can I see the problem that you did before?
This is wrong. This is not. This doesn't make any sense.
Yeah, something's not right. D4 to D14. That is correct. Sum is correct. Yeah.
4.
Okay. All right, hold on. Each individual observation. minus EA.
Well, how can it be 69 for a mean?
Well, if you think about it, what is the most common number in your data set? The most common demand. What's the highest likelihood for the demand?
14.
14.
No, 13. No, 14.
14. So now take 14 and multiply by 5. What do you get?
60.
70.
70.
Right? That's close to your mean here, right?
Oh, okay. Yeah.
So we're good with that. So now, what I'm trying to figure out is,
Well, this would be in dollars, right?
yes. 2.5. Because, okay, it's the X side that's wrong. All right, let's do this. Could you just show me 27? I want to see what we did on 27 for a second. Okay, scroll back up. All right. Now here, whoops. Oh, I just lost it. Clear all things. This is 27, right? Okay, so we added this up, right? Now let's take a look at what we subtracted. What did we subtract here in D4? You subtracted A4, right?
Uh-huh.
From this mean, which is this piece, right?
Right.
Okay. Now the problem is that you're subtracting what you computed here from this. Remember when I said it would probably be easier if we had calculated the total money for the full demand?
Right.
Recall that? Let's do that. Let's go back to your slide. Let's go back to your other spreadsheet, right? What I want to do is insert a column here.
Between here?
Between A and B, yep. Nope, the other way. Undo, Control Z. There you go, click on B and click Insert. Okay. Now what I'd like you to do is I'd like you to take the demand and multiply it by 5. Good. Take that all the way down. Just double click on that dot. Double click. All right. Now in your F column over here, the XI is really this column B. So instead of doing, I think you did what would be E, I want you to do B4 minus.
Up here?
Down, go down. Instead of E4, you're going to make it B4. And then copy that all the way down.
E6.
Yep, hit enter.
Yeah.
Good. Double click on that little dot, just double click. Right, that's fine. Okay. Now, okay. So now you've got your D62, right? D62, D caret 2, which is where you squared it, correct?
Is square this.
Could you just double check all the numbers? I just want to see something. Go to all the numbers for one moment.
Yes. Yeah. Okay.
Interesting. Okay. Scroll down, and you have your variance, and you have your as long as the other, check that other formula too.
Which one?
One to the right. G4 times C4 times its probability. So it's the D squared times the probability. That's correct. Okay. And you get your standard deviation.
That was from, well, variance was from.
Right. So now what it basically means is that your probability, the average is 69.05 and the standard deviation is plus or minus 10. Okay. Now, what does the question ask?
Fine. Assuming it costs $5 to purchase ream of paper, find the mean and standard deviation of the weekly copier paper cost for this corporation.
So does it make sense that the mean is 69? Did we figure that out?
Um,
Remember we did that before? You know, what's the most common number that you
yeah, it
would get?
was 14, about 70. So,
So your mean looks pretty good, right?
mhm.
The standard
So about
deviation
70, 80 to 80 to 60 to 80.
handles now if you highlight the probability of the 60 to 80.
And that would be down here it should come out to 60. What's this? 68.
68. Yep. If you highlight the probability for the
Uh,
60 through 80.
60 through 80. So here,
Yeah. What do you got?
75%.
About 75. So that's fine. It's in the ballpark.
Uh-huh.
That makes sense?
Yeah. Okay. Thanks.
Okay. Is that it?
For now.
Okay.
There's other people.
Okay. All right. Let's see. Who is next on the list? I think next caller is Sandra. I think you're next.
Yeah, hi, Professor. I have a question on, so I have a question on Chapter 4, 27, question 27, Part E. So I'll share my screen.
Mm-hmm.
Can I share right now?
Yep, you can. Go ahead.
I cannot start. Okay, all right. Okay, hold on. Okay, this is what I have. So I did what did I do?
Oh, this is the same
Oh
one.
wait, no, I'm talking about the chapter, sorry, chapter 5, question 48. I'm sorry, I'm so confused. Okay, so I don't know how to do E. I was wondering if you could give me some direction.
Okay, what does E say?
E says, assume there are 252 trading days in a year.
Mm-hmm.
What is the probability that ABC will lose money on a given day?
Mm-hmm.
And it says hint, like Y be the annual return on ABC and XI be the return on ABC on day I.
Right.
Then approximately Y equals to X1 plus X2 plus all the data.
Yep,
So I was wondering, do I need to create a table?
Nope. What's your annual return? What's the average return?
My annual return is at 15%.
What would the average return be on a particular day? Think of an interest problem. If I earn, and I'm going to use this, if I earned 100% interest in 100 days, what would my interest rate be per day?
100%.
No, per day.
One per day in 100
Correct.
days?
Now,
Yes.
if I had 100% over 300 days, how much would it be per day?
300 divided by 100.
100 divided by 300, the other way.
Oh, okay, yes.
Okay? So now I have 15% as my average. And how many days does it say for you to assume?
252, I
So,
wrote here.
okay, so what's my average return for the day?
Oh, okay. So it's just equal 252 divided by,
The other way around.
oh, wait. Okay, sorry. Equal 10 divided by 252. This will be it.
Correct. And the standard deviation, you do the same thing. Because the standard deviation is for the year, you're just going to do the standard deviation for the 252 days.
So I'm sorry. So all I need to do is just use the standard deviation divided by the amount of days?
Right, 252. And you would get the standard deviation per day.
Oh, that's it?
That's it. Now that you have the mean and the standard deviation, you can answer the rest of the question.
Okay. And one more question is the part C. I feel like I did something wrong.
What is part C?
but I don't know what did I do. Part C is there is a 10% chance that ABC will earn a return of less than or equal to what value during a year.
Okay. So they've given you the probability, correct? 10%.
10%. So this is what I did. This is my formula.
Okay, go down a little bit for 1 second. Go down to like a blank cell. The norm
Okay.
dist function takes a value and gives you the probability, right?
Correct.
Now, if you given a probability, you have to do the inverse of that. So we would use the norm.inv,
Norm.inv.
open parenthesis, so that we can see what it takes as a parameter. But you're going to have to put an equal sign in front of it.
Yes, I will do that.
Now, what does it say it wants? It wants at least 10%?
It wants, no, it's between. So if there's 10% chance, they want the return of less than or equal to what value during a year. So do I put like 9%?
No. You're going to put in 10%. So we'll put in 10%, but you're going to have to give it the mean and the standard deviation now. Now let's think about this for a second, right? And we're going to think about this from a, draw this out. Go ahead, you can run that.
I can run that, okay.
Yeah, go ahead and run it.
Enter too much.
Take out the, just take out the true for 1 second. Equal norm.inv and just remove the true. The true is for the
Okay.
dist. Get rid of the comma too.
Oh, that's right. Yeah,
Okay.
that's right.
Now,
Sorry.
I have no idea if this is correct, okay? I'm gonna play it, we're gonna play it like this though. Here's my normal distribution, right? Our friend normal.
Okay.
What is this?
That's the average. So it's
That's
gonna
the
be,
average. What is our average? 0.15,
it's
right?
0.15, correct.
Okay. Now, read me the question again.
There is a 10% chance that ABC will earn a return or of less than or equal to what value during a year.
So a 10% chance, right? So anything here is 50%, correct?
Correct.
All right. Now, if I were to, there is a, you know what? I got to pull it.
You want me to send you the question?
Yeah, can you please send me the question? Because I want to make sure I'm interpreting it correctly.
Yeah, sure. Just give me a second, though. I wrote a bunch of stuff on it, so just give me 1 second. I'll send it to you.
Because this is a directional issue. If you can paste it on here, that would be great, like on this Excel sheet.
Oh, I don't know how to do that, so
Okay, it's fine.
sorry.
No, it's okay. Which one are we on? See, there is a 10% chance that ABC will earn a return of less than or equal to what value during the year. Okay, so if I look at this of less than or equal to, so immediately I'm going to just draw an arrow. Less than or equal to would be this way, right?
Correct. Yeah.
All right, so a 10% chance that it will earn, I hate the way they worded this question. I know this one, so I'm trying to make sure I word it correctly for you. If I were to do this, let me change the color. In this case here, there is a 50% chance that it will earn this amount or less, right?
Correct.
Now, if I were to take a line, let's say here, because I want to make sure we do the interpretation properly, I'm going to do here, and I'm going to make this 0.25, right? We're going to say that the area under this curve here is 25%. There's a 25% chance that it will earn this amount, correct?
Correct.
Or less,
Mm-hmm.
right? And
Yeah.
if I were over here, this would be a 10% chance that it would earn this or more. You follow?
Correct.
Okay.
Yes,
That's
I
why
do
it's
follow.
important to look for the direction of this thing, of what it's asking for, right? So if we do that and you now use this as your 0.10, it will give you this amount because it's looking for the less, right?
Correct.
But if we wanted the more, then this number wouldn't be 0.10. It would be the 0.90 because this whole thing
Correct.
would
Yes.
be 90%. Does that make sense?
Mm-hmm.
Okay.
Yes, it does.
So in this case, for you right now, you're going to put your 0.1%, and you have you came up with 0.17, negative 0.17, right?
Correct.
All right. Now let's see if that looks about right. So if I'm doing this handy dandy little chart again, and here's my normal distribution, and here's my median, and my median is 0.15, right?
And then negative 0.017 is less, so it's possible that it's correct.
That's correct, but we can do a little bit more, right? So let's do this. If I were to say that this line and this, what the hell was that? Okay, you're gonna have to bear with me on that line. So this line and this line constitutes 68% of the data, right? What did I just describe?
You described the standard deviation is plus and minus 3.
Plus and minus 3? How'd you get 3? You were right about the standard deviation. 68% of the data lies between -1 and +1 standard deviations, right?
Correct.
So what would this number here to the left be?
Oh,
if the mean is 0.15 and a standard deviation is 0.25, what would this number be?
So it will be 1.16.
How'd you get
on one side?
How'd you get 1.16?
Is it 1 plus? Isn't it 1 plus 0.15?
No, all you're going to do is you're going to subtract the standard deviation from the mean for one direction and add the standard deviation to the mean for the other direction.
So it will be 0.44.
0.4. How'd you get 0.4?
You say mean plus the standard deviation, right?
Right. So so that's 0.4 on this side. Okay, I'm just going to the wrong side. So this side is this side is 0.40, right? What's the other side?
The other side will be minus, so it will be negative 0.15 minus 0.25. So just late. I need a calculator right now.
Okay.
So it will be negative 0.1.
Correct. So that's a negative 0.1, right? And you said, now, if I were to go this way here, this would represent here and to the left, 34, about 30, 34% of the data. This is 34% of the data, right? Here. And this is 34% of the data here. So that would leave you with a smaller amount on the left side, correct?
Correct.
So this, let me ask you a question. If this is 34, I'm going to erase some of this really quick. Okay. Erase this. This is where we play around with this normal distribution and stuff like that. 68% of the data lies within one standard deviation. That means if I cut it in half, whoops. That means how much is this from here to here?
34.
34%.
And the other side the same.
Right. So, but I'm concerned with this side. So this is 34, and the total was how much? The total from
68.
here to here, actually, the total from this point to this point is how much?
It will be 100.
Nope, just from the mean to the left would be how much?
Mean to the left.
The whole data set is 100%. Your mean
Right.
is right in the middle, so the full left side would be
0.5.
how much?
It will be 0. It's just half. That's
50%, right?
Yes.
Cool. If that's 50%, and this left side of the standard deviation is 34%, how much is in here?
It's 16%. Sorry.
16%. Excellent. So
Yes.
now what happens is you said that the 10% marker, right?
Yes.
I'm going to do here that this is going to be only 10%, right? And
Mhm.
the whole thing from this side, you said is 16%. From here out is 16%, right?
So there's 6% in the middle.
And that number is negative 0.10. So if I go a little bit further, it is plausible that this number here is negative 0.17, isn't it?
All right. Don't delete that, please. Can I take a picture so I can remember? Thank you.
You can absolutely take a picture. Just give me 1 second. Hold on. Now you can take a picture.
Thank you. Thanks. Got it.
So does that make sense?
Yeah.
This is how,
I got
when we look at the normal distribution and we look at these standard deviations, you want to make sure that you understand what we're looking at in front of the first, the left side and the right side. The amount of
I think I
data
was
here
just
under the
getting
curve,
really
the amount of
confused.
data here under the curve. Because it'll tell you whether or not the answers you get are plausible.
Okay.
Okay.
Thank you. I'm so not used to this. I have to get used to this, the statistic stuff.
That's fine.
Thank you.
Okay. All right. Let's see who's next on the list. That beautiful chart just went through the roof. Steve, I think you were next. Steve Harberluck?
Yeah, can you hear me?
I can hear you. How you doing?
Okay, pretty good. Sorry about that. My computer's acting a little glitchy. I'm just here to observe. I don't have any questions at the moment, besides which I'm on a different laptop than the one I normally use, so I can't even share my screen for any questions I do have. But thank
No
you.
worries. All right. I don't know your first name, Benegas? You're up.
Hi, how are you?
How you doing?
I'm
Sorry.
good. I just I see for the first assignment we have a lot of chapters to do.
Yeah, but don't go too.
And I just wanted to know if you'd be willing to look at some of it while we're going along, or you just want the whole assignment.
No, well, if people have questions, you can ask, and I can take a quick look at them. So.
Mm-hmm. I mean, the skewness sometimes throws me off a little bit. So
Okay.
if the skew is 0.09, does that relatively mean that the skew is 0?
Yep, it's relatively symmetric. That's fine.
Okay, good.
Okay.
All right, and then you answered my question about the percentile. So that was, those were the 2 questions that I had.
All right. Any other questions?
Nope.
Eric? Okay. Eric, you good?
Yeah, I have a question on number 50.
Go ahead.
One about housing costs. They list the house, the mean and the standard deviation where their family currently is, and then they give another more values to move to California,
Mm-hmm.
and what the family's current house is valued at. And the first question says, what percentage of houses in the family's current city cost less than theirs? So basically, I took their house, 105,000. I subtracted 18,200, and and I got 86,800. I'm not sure if that's right for one standard deviation.
What is it? Okay, read me the question again.
What percentage of houses in the family's current cities cost less than theirs? So basically, I did that.
So
Calculate.
what you can do is if you use the norm dist function, right?
Uh-huh.
The norm dist function, and you put in their value, right? You can, the value for their house, along with the mean and the standard deviation. It will give you a percentage that is to the left of that number. So if you were to look at the standard deviation, if you were to create a chart of this, right, might look something like this. I take my.
Wait, do I need to share my screen?
Yeah, you got it.
All right.
All right. So let me draw the chart anyway, just so that we can get an idea. If you basically were to, oops, don't want that. So I've got this, right? And I draw my normal distribution, and I do this, and here is my mean. Now what was the mean?
105,000.
105. Where is their house?
Where is their house?
What's the amount for their house?
105,000.
Oh, and that's the mean?
That's the mean.
Right. How much was their house? 105,000 too?
Oh, 110,000.
110,000. So I'm going to draw this here, right? 110,000. Now it's asking you what percentage of the homes are less than the family's house?
Correct.
Okay. So looking at the chart without doing any math first, what percentage lie below this average this way?
50.
50%. So the number of houses that are going to be less than their 110, is it going to be more or less than 50?
More.
More. So a lot more or a little more?
Little.
Little more. Okay. So now what we're going to do is, now that you have an idea that it's going to be about 55, 60, 65, somewhere like that, right? And we could get a little bit more accurate, but we don't have to just yet, is let's use the norm dist function. So in one of the cells, I would like you to put in the norm dist function, equals norm dot dist. An open parenthesis. And now what you're going to do is you're going to put in the number, which is their house. So I think it's going to be 110,000. You can't use a comma there. Okay, now comma. Now it's asking for the mean. So you put in the mean, comma, and then you put in the standard deviation. Comma, and then you're going to put in true for cumulative. Oh, and then close the parentheses. Now remember, you said it's going to be slightly above 50%, right?
Yes.
Cool. So run it. What do we got? 60%. And I think that's the right answer. Don't you?
Yeah, makes sense.
That's how you do these problems.
Mm-hmm.
The norm.inv does the opposite. If they give you a percentage, it will tell you what the value is at that percentage. So in other words, if they say 60% of the homes fall below this amount, what amount, you would do the norm dot, watch this, underneath that 60%, I want you to do that. I want you to do equals norm.inv. Open parenthesis, 0.6 INV.
MD.
INV, yep. Open parenthesis, that stands for inverse. 0.608. comma, put in the mean and the standard deviation. 105,000, comma, 112,000. We should get a number close to 110,000. That would be the number at which 60% or 60.8% of the houses fall below. Close parenthesis. Enter.
No true on that.
Not for the INV, no. See that?
Okay.
So it's a little bit higher, probably because if we want to be more exact, put in that 135,700, put in the norm.inv, change it to 608,236.
What's that?
105. Oh, your standard deviation's way off.
He actually put the wrong column in, that's why.
Yeah, you
I just
put
did
100.
mine, it's correct.
What's that?
The standard deviation, I think you have there 112,000. That can't be right.
Oh yeah.
He put the standard he put the current house price instead of standard deviation, that's why.
Oh yeah.
Go ahead. And that's your 110,000.
Right.
Okay.
Okay.
That makes sense?
I think so.
All of the
Yeah.
probability distributions, the Poisson, the uniform, well, you don't do uniform, exponential, will basically be the same way. So if you understand how you're doing it with the normal distribution, it's the same principle with the other ones. Okay?
This is normal distribution based on
That's correct.
which is most things we do.
Correct.
Okay.
All right. Any other questions?
No, that was cool.
Are you just
See?
asking in general?
Told you math is fun, didn't I? Okay. Go ahead. You had a question, Natalia?
Yeah, I can go. So back to that question we were talking about before. Just wait. I can't share my screen because he's.
Hold on. Go ahead.
So I know that you said these are right, but I feel like with these graphs, it's hard to see the correlation. So how do you do that graph that I showed you a picture of before? Because do you know what I mean?
Let's see something. Hold on. You know, show me that other picture that you had before. I want to see what that was.
I think it was Sandra's graphs.
Yeah, that's mine.
Yeah.
Like, I don't know how she did that.
I think they were ordered. You're not as good as this.
I remember it took me a while. I think I changed the X and Y or something. I did something to it.
Did you still do like insert scatter though? Is that what you did? Like, how did you get the line? Because it's easier to see the correlation like that.
Well, hold on one second. Let me just check. I want to do this first before you do anything else. You said you can't see a correlation, correct?
Yeah.
All right. Let's check to see what the correlation should be. So I want you to do a correlation of those three columns.
So this?
Yep.
Okay, so you would have to do the data analysis, right?
Yep.
I had a problem with this last time when I clicked it.
Now your input range isn't right. It should be G1 through I726.
Oh.
I'm not even sure if 726 is the right number, to be honest with you.
Let's see. I'm pretty sure it is. That's where the data ends. Oh, selected everything. Yeah, wait.
Yep.
726.
Nice.
So, wait. So is this right or no?
So you got to do $1 to I726. Just
Wait,
change the first 726 to a 1.
Okay.
Labels in first row, change your output range to like N1.
Why do we change it to G1? Oh, because that's the first. Oh,
Yep.
okay. Where'd it go?
It's underneath your chart. Go all the way to the top.
Oh,
Right over there. Just move that graph. All right. Now, do you see what is the correlation?
it's negative.
No. It is negative, but would you say there is a correlation or not?
I would say.
So in your charts or in the PowerPoints, you should have a couple of rules of thumb,
Yeah.
right? Anything less than 0.2, and really it's like 0.18, there's no correlation.
Okay.
Okay, absolute value. Okay, so the absolute value of your correlation less than 0.18, there's no correlation. Okay.
Okay.
Your chart is correct.
Where'd you get the 0.8 from? Or
Point. The 0.8.
I could have sworn you said 0.8 or something.
I'm sorry, 0.18.
0.18.
Yeah. So there should be a small table on one of the PowerPoints that tells you for the correlation, a weak correlation, a small weak correlation, medium correlation, strong correlation, very strong correlation.
Yeah, I'm looking at it right now.
Okay. You take the absolute value of the correlation, and then whatever it falls between is what the number is. Okay.
So I'm still confused. Where'd the 0.18 come from? Because this is 0.006.
No. You're comparing it to those numbers. So given anything below 0.18, there is you take the absolute value of your correlation. If it is less than 0.18, there is no correlation. Does that make sense?
I don't know where it says that, and then.
I'll have to find the exact slide. I know there's a slide somewhere.
Okay. So the correlation, is it, I'm still confused.
Which part?
Because the question asked for the scatter plot, so that's the two things that I have here.
That's correct. Do you see any pattern there? If you got to say chances are you don't see a pattern, correct?
Yeah.
Okay. And your correlation is basically close to zero, correct?
Mm-hmm.
Therefore, your patterns, your scatter plots and your correlation match.
So there is no correlation?
That's correct.
Okay. So do I need any of this information here then? That's just an assumption.
No, yeah, you don't need that. If you assumed it, and the information that you just gathered is different, then the answer is whatever you just said now.
Okay. Okay. Thank you.
Okay. Okay. Any other questions?
Yeah, I got another question.
Go ahead.
Going back to question 15, chapter 5.
Mhm.
I think I got the right answer, but I'm just trying to look at it conceptually with the graph. It's basically saying, well, let me share my screen.
Yeah, share your screen.
So if the family buys a $200,000 house in the new city where the mean is 235,000 and its standard deviation of 30,000, they want to know percent of houses will cost less than theirs. So I did this
Yep, well, that's right.
equation here. You don't say, why don't you say Q and say true?
Because, okay, that's a good question. I'll tell you why. What happens is this. In the probability distributions, what we're looking for is, whoops, you moved it a little bit. So let me erase that. Here's my normal distribution, right?
Yeah.
Now, if I draw my mean down here, I want the area under the curve, or the full probability from this point to the end, correct?
Mm-hmm.
And that is how much from the mean? What percent?
50%.
50%. But if you say false, it is not going to give you the cumulative distribution of 50%. It is simply going to give you the probability at this point exactly.
Mhm.
Does that make sense?
I think so.
Okay. So all of this to the left is 50%, but this point is going to be a lot less. Because remember, the cumulative is adding up all of the stuff to the left.
Mhm.
We really, and that's called a probability mass function or density function. We don't, the cumulative density function is adding up all of those densities.
Okay.
The density being the mass underneath the curve.
Mhm.
Okay.
Can you do the graph here with this question? I'm just trying to conceptualize it. So
Which one? The one you just did?
yeah, so basically right down the middle is 200,000.
Right. So
I'm
this
sorry,
is,
no.
okay. Where was their house?
I'm sorry. The mean is, this is 235,000,
Okay, hold on, let me erase that.
right? Because
So
that's
the
the
mean
mean.
is 235,000.
Standard
Okay.
deviation's 30,000. So
Okay.
about.
So if the standard deviation is 30,000, you said, right?
Mm-hmm.
So that means that 68% of the data will lie between what and what?
34 and 34%. 60 will lie between 200 and 265.
265, right?
Yeah.
Where is their house?
Their house is at 200.
200 exactly?
Well, I mean, yeah.
Close enough, right? Actually, this shouldn't be 200,000. This should be 205,000. Okay.
Yeah, you're right. Yeah,
Okay.
exactly.
This is 205,000.
Yeah.
205,000.
So slightly.
Right?
So if that's 34, the other would be 16.
16, and you said roughly around?
I said around 13.
Bingo. In the ballpark.
So just remembering that one standard deviation is about 34% on each side.
On one side of the mean,
One
34
side.
on the other as well.
Yeah. Okay.
That's why that helps you.
And then is the next question an inverse one with what price house will the family need to buy to be in the same percentile? We're dealing with percentiles now.
It's the same thing. The
In the-
probability and the percentiles here in this distribution will be the same thing.
Probability and what?
And the percentiles will be the same thing. When
Mhm.
we're dealing with the distributions here, if the 50th percentile is the mean, isn't it?
Correct.
So it's the same principle. Don't get confused with the words. You're not going to use a percentile function.
So what price house will the family need to buy to be in the same percentile in the new city as they're in the current city? In the current city, they're at 110,000, and
And what percentile was that?
110,000 was yes, 61%.
So now you'll do your norm in for using the other information at 61%.
Norm in, so yeah. Probability would be 60.6.
Yep. 0.608. Mm-hmm. What's the mean?
Mean would be 110.
No,
No.
because now you're dealing with the new city.
New city, 235.
235, standard deviation.
30.
What price house?
250.
243,000.
Agree. It's basically saying the new city.
And that lies right around here, doesn't it?
What's that?
That lies right around here. Doesn't it? The blue line.
Blue line. Yeah, slightly.
That's the 61%. That's around 243,000. Wouldn't you agree?
Yeah. Another 10. Yeah, or 10% of 230. Another 23,000. 10% of 235,000. Right.
Yeah, but
we can't look at it like that.
You can't do it like that, right? You got to focus on the probabilities.
Yeah. Okay, but it's lying more than the mean here.
That's correct.
Okay. All right, I'm gonna work it out again.
Cool. All right. Any other questions? Natalia, you good?
I have more, but I don't want to keep people up.
Okay. All right, Sandra, you're up. You're okay?
Can I bother you with one last question? I'm done with chapter 5.
All right, go ahead.
Oh, by the way, one of my team may want to know if you're going to post this on Zoom.
Yeah, I'll post it on. It's on Zoom. I'll post it on YouTube.
Oh, okay, YouTube. All right. The last question is chapter 554. I only did very basic because I'm confused.
Mm-hmm.
Can I share my screen with you?
Yep.
Okay, this is what I have. Excuse me. I send you did I send you the question? You need the question, right?
Yeah.
It's a long question. I think it's better off I send it to you. Okay, you got it.
Okay. What's your question?
54.
Yeah. What's the question? I know that I see the problem. What's the issue?
So it says find these two probability, how they compare to one another.
Mm-hmm.
So this is what I did. This is my calculation. So when P is less than 65, I did this, and if the P is more than 95, it will be 14.
Okay.
So when they compare with each other, there's a huge difference. I mean, do I have to time something with the per share of the stock?
No, because they're only looking for the change with a mean of 1 and a standard deviation of 8, right? You only need, so if I know that the change is 1, right, and they're looking at a P be a big loss that the price falls below 65, and your average is, where's the average? Current stock price is $80, right? Mm-hmm. Then you know that if it drops below $15, right?
Yes.
That's how you do it. You're looking for the drop of $15. You're looking for the increase of $15 for your big loss, big gain.
So it's basically 1,000 times 65.
You don't have to multiply anything. Nope. If you break down the problem and you get rid of a lot of extra stuff that they wrote in there, you're only focused on the fact of the change in the stock price. And it said the average change was $1 as an average, correct?
Yes.
So you're looking for the probability that the change would be less than $15 or greater than $15. because that would give you a stock price of 65 or 95.
Oh, you're right.
Thank you.
Okay. Okay.
Give that a shot, okay?
All right. Let me try to do it again. All right. Thank you.
Okay. Natalia, you got a few seconds to ask your question. Go ahead.
I feel like it's gonna be a lot, but
Well, let's see. If it is, then we'll postpone it.
okay. It's a totally new question. That's the thing. I'm pretty sure Sandra did this question. All I remember is like after this column, she put a bunch of yeses and nos for some
Yep.
reason. I don't know.
So let me do this. If you look at the other videos that are in Slack,
Okay.
it will be there and telling you how to do it. Okay, is that fair?
Okay, so it's from a video that you made?
Just in the last, well, it's one of the Zoom sessions.
Okay.
Okay?
Okay.
If you look at the videos, you should see them there.
Okay.
Because I've done that a couple times, not just for Sandra, so it's okay.
Okay.
All right?
Mhm.
All right. If nobody's got any other questions, Eric, you good?
Yeah, for tonight, I'm good.
Cool. All right. Natalia, you good?
Yep.
Sandra, you good?
Until the next time.
Wait. I have one little question here. So the
Go ahead.
question I just asked, I'm sorry. I'm literally, this is like, it's worse than math. But anyway, the question I just asked you say plus and minus 15.
Right.
As long as I calculate the number for plus and minus 15, which the calculation I should use the norm dot invert, right? 15 plus the mean and the deviation, correct?
Well, again, it's based on, if you look at the question, it'll tell you, you kind of infer. If it's giving you a probability, you're using the inverse. If it's giving you some numbers, you're using the dist.
This is $65, so I used this. All right,
Okay.
thank you.
All right.
All right, thank
All right. So you're okay. Steve, you're good?
Yeah, I just had a real quick question though. Are you gonna have office hours on Tuesday before class?
Yes, I will have office hours. I should be there by 7:30.
Okay, thank you.
Okay. And then, I'm sorry, I didn't actually get your first name. Benegas?
Maria.
Maria. I thought it was Maria. Oh, you're good?
Yeah, I'm good. It was great. Thank
All
you
right.
so
I will post this as soon. It takes about an hour to render, so it'll probably be up in the morning. Okay.
Okay.
All right, everybody. Have a great night.
Good night.
You too. Thank you.